Citizens of the future, welcome to our presentation on MavColSAR, an innovative project developed by Team Mavericks for the Smart India Hackathon 2024. We're excited to share our work on colorizing synthetic aperture radar images using deep learning techniques. Synthetic Aperture Radar, or SAR, is an active microwave-based imaging system used to create high-resolution images of Earth's surface. Unlike optical sensors, SAR can operate day or night and through cloud cover. SAR images provide rich textural and geospatial information. However, SAR images are typically grayscale, which can limit their interpretability. Our project aims to address this limitation by colorizing these images. Before we can apply our deep learning models, we pre-process the SAR data. This involves converting the raw SAR data, often in complex formats like COSAR or CEOs, into more manageable image formats such as TIFF or PNG. We also normalize the data and apply noise reduction techniques to enhance the quality of our input. The first key component of MavColSAR is CNN4-ColSAR, a convolutional neural network designed for SAR image colorization. This network consists of multiple convolutional layers with ReLU activation functions. It learns to map grayscale SAR images to colorized versions. In MavColSAR, CNN4-ColSAR serves as an initial colorization step, producing what we call an intermediate colorized SAR image. This intermediate result is crucial as it provides a starting point for our more advanced GAN-based colorization. Our CNN is chosen for its efficiency in handling image data for colorization and ease of integration with our broader pipeline. Here's an example of an intermediate colorized SAR image produced by CNN4-ColSAR. As you can see, it adds color to the original grayscale image, but there's still room for improvement in terms of realism and detail. The heart of MavColSAR is CGAN4-ColSAR, a conditional generative adversarial network. This architecture consists of two main components, a generator and a discriminator. The generator takes our intermediate colorized SAR image and refines it further. It learns to produce increasingly realistic colorizations through an adversarial process. The discriminator, on the other hand, tries to distinguish between the generated colorized images and real color images, our ground truth, which we'll discuss shortly. This adversarial relationship pushes both networks to improve over time. In MavColSAR, CGAN4-ColSAR takes the output from CNN4-ColSAR and enhances it, producing our final colorized SAR images. This two-step process allows us to leverage the strengths of both CNN and GAN architectures. Our GAN is implemented with custom layers and loss functions tailored for SAR image colorization. A challenge in SAR image colorization is the lack of naturally colorized SAR images for training. We address this using a technique called Generalized Intensity Hue Saturation, or GIHS fusion. GIHS allows us to combine SAR data with multispectral satellite imagery, creating realistic color representations of SAR scenes. These fused images serve as our ground truth, providing a target for our models to aim for during training and a benchmark for evaluation. We use a min-max loss function to train our GAN and evaluate our results. This function helps balance the generator and discriminator during training. Our final output is a colorized SAR image that closely resembles our GIHS-fused ground truth, but generated solely from SAR data. MavColSAR differs from previous approaches in several key ways. 1. We use a two-stage process, CNN followed by GAN, for more refined results. 2. Our ground truth generation using GIHS fusion is more sophisticated than simple false color composites. 3. We've tailored our architecture specifically for SAR data, accounting for its unique characteristics. MavColSAR is highly feasible for real-world application. It can process SAR images from various satellites and can be deployed on standard GPU hardware. Key advantages include 1. Improved interpretability of SAR images. Potential for better feature extraction in downstream tasks. 3. applicability in areas like disaster response, where optical imagery might be unavailable. Our work is particularly relevant in light of the upcoming NISAR mission, a joint venture between NASA and ISRO. NISAR will provide unprecedented amounts of SAR data, and tools like MavColSAR could be crucial in making this data more accessible and interpretable to a wider audience. While powerful, MavColSAR does have limitations. It may struggle with extremely complex scenes or SAR images significantly different from its training data. Ongoing work aims to address these challenges. Hope you've learned something new today, and thank you for following us till the end.